Hi everyone, today let's solve this code question called a sort list. So given linked list, we want to return the linked list after sorting the linked list in ascending order. In other words, from the smallest element to the largest element. For example, in example 1 here, the original linked list is not sorted. If sorted linked list, will go from the smallest element 1 all the way to the largest element 4. Okay, so this question, I think the problem description is clear and very easy to understand. Now let's think about how to solve the problem. So actually for this problem, we can use a variation or merge sort. Merge sort is very classical sorting methods usually used for arrays, but here we want to use it for the linked list. Let me show you how. So let's reuse the example for this example 1. We had 4, then we had 2, and 1 and 3, right? And the first thing, merge sort find mid element. So how can we find the mid element from the linked list? Well, we're starting with slow pointer and fast pointer at both beginning. The slow pointer will traverse 1 at each time, and fast pointer traverse 2 each time. So after one iteration, slow pointer is right at this position, and fast pointer is right at this position. If we break the slowdown x, which is this one, we actually split the original linked list into two halves. So one half is this 4 and 2, and the other half is 1 and 3, right? Okay, now finish finding the mid element and break the linked list according to the mid. The next thing is to actually sort the pairs we get, right? Okay, so let's use a different color. If we sort this pair, this 4 and 2, it will be 2 and 4 because 2 is a smaller element. Okay, so write it out here. And do the same thing from, okay, this one is 3. If sort this one, it again will be 1, 3 because it's original sorted. Okay, so the final step is to merge the sorted pairs. So for this merging, actually we can start at both the beginning for the pairs. So this pair we are starting at 2, and this pair was starting at 1. Now we want to compare is 2 smaller than 1 or greater than 1? Okay, 2 is greater than 1. So we want to write in result array 1 before the 2. Let me write here. Here the result array, we have 1 starting, and then followed by 2. Now finish 1 and 2, so just cross this out, and then want to check the next numbers, right? So next number for this pair is 3, and for this pair is 4. And we want to compare the relationship between 3 and 4. Obviously, 3 is smaller than 4. So we want to append the 3 right after the 4. So let me write that here. Okay, 3 here, and finally we are left with 4. Okay, so these are done, so cross it out, and this will be our sorted array. Sorry, the sorted linked list. Okay, now finish the explanation. Let's dive into the coding part. Okay. So the coding thing is a bit long, so I'm trying to make less mistakes during the coding. The first thing is to recursively call the midpoint and write it out here, and then want to sort each pairs and merge them together. Okay. Okay, so the first thing we consider in this problem, if the corner case is right. If the head does not exist or head on next does not exist, we want to return head. So for example, if head does not exist, it's empty, so we return empty. If head on next does exist, this means it's single element, so we just return the single element. Okay, the next thing to record the midpoint, let's call the function getMid, which I will write later by passing head, so I'm getting the midpoint of this linked list. And after I want to record the mid.next, right? We want to temporarily record this mid.next because we want to break the mid.next later, so we can break the linked list into separate pairs. Okay. Now next thing to sort each pair. So let's say we have left pair and right pair each time recursively. Pair, let's call the sort list function recursively, and want to pass temp because temp is the head of this left pair. And then want to have the right pair. Let's copy paste this function. And we want to pass, sorry, here should be head, because head is the beginning of the left pair, and for the right, we want to pass temp, because temp are the beginning of the right pair. And after that, I want to merge the left and right. So I will call a merge function later, and just write out here that is the result will be the merge result. Right, we turn the result, it should be done. Okay, now finish the main function, we actually have to write two helper functions, right? So one helper function to get the mid, and the other helper function is to merge the left pair and the right pair recursively. Now first thing to get mid, so just pass the variables self and head. Now, as I mentioned before, we are using the fast and slow pointer techniques for this. In this, we initialize fast and the slow pointer both at head, and while fast and fast don't act. If you remember the previous question, we write like this. But here we don't want the fast, for example, stuck one space before the end of linked list. And if we do this, and the fast stuck at one space before the end of linked list, then our slow pointer will not reach the mid, but one space before the mid, right? So to avoid this case, we want to change here to fast.next and fast.next. So if that is the case, fast can either arrive at the end of the linked list or arrive 2 steps before the linked list, and you can travel to the end of the linked list after the next iteration. Okay, now finish that, just copy paste here. So low will travel at original speed, but fast will travel at double speed. Okay, so let's scroll it down to here. By the way, in slow, it should be the middle of the linked list. Okay, now finish the get mid function. Next thing to merge the left pair and right pair recursively, right? So let's say the right here, left here. So first thing to consider is that it's not. So the corner cases means if either the left and right is not. The other thing to consider is the left is left bell smaller than right bell. And final thing is left is greater than right. Okay, the first thing, if there's no left or there's no right, we turn left or right. This means if there's no left, we just return right, and if there's no right, we just return left. Okay, the other thing consider if left doorbell is smaller than right doorbell. In that case, we want to begin the linked list with left, right? So we have to return left. But before that, we have to recursively check all nums in the left pair. So left equal to self merge, and left, this one will left or next, and this one also left or next, because we are checking the next numbers, and this one should be right. Okay, now we do the same thing. If the right is smaller than left, otherwise the left greater than right, right? And if that case, we want to recursively check the next number for the right. So just call this function and merge here with right dot next and have this left. Okay, finally return the right because the new link is starting and right. Okay, now let's submit code to it works. Oops, it doesn't work. Okay, so let's check where do I make mistake. Okay, here it should be not head on X, sorry. And this one should be correct. Okay, here we should return the right. Okay, let me submit again to see it works. Okay, you see the time capacity memory usage of this solution is not bad, right? And although the coding part is long, I think the logic is very easy to understand. Okay, if you find this video helpful, please subscribe to our channel, and I see you next time. Thank you.